Good morning, students. Today we will start second chapter, that is work, power and energy. So let's start with work. Now by the term work we means to do something. But the concept of work can be explained according to English vocabulary and according to physics, but absolutely into different aspect. So far in according to English vocabulary, we have learned parts of speech, and in that parts of speech there is a parts of speech called verb, isn't it? So verb means to do something, isn't it? Walking, singing, talking, sleeping, jumping, anything. Even the most ridiculous and amazing fact is that to do nothing is also considered as work according to English vocabulary. If someone challenges that I will confine myself, capture myself inside my home, closing all the windows and doors, and I will do nothing. I will abstain from doing any sort of work. I will just keep sleeping. The most astonishing fact is that it is also considered as work, that is verb according to English vocabulary. But in the point of view of physics, according to physics, the concept of work is absolutely different. So let's see. Now physics says with the application of force, when we apply force on anybody, and if it displaces, it means if it moves from one place to another, only in that case work is said to be done. So generally in physics, rather than work done is generally has been given more priority. Work done. Work is noun, but in case of work in physics, it is generally given more importance instead of work on work done. Work done has a key contribution, the most key role in physics. So it means work is said to be done when under the force a body displaces. So it means work done depends on two factors, that is force and displacement. It means if we move any object, if the body doesn't displace, if it is not moved, then it is said no work done. It means in that case work done is zero. There is no work done. Clear? Force obviously will be there. So work done depends on two factors. One is force and one is displacement. Both has to be present there. Without force the body cannot move. So how it can be work done? So it means if we apply, if two persons applying same amount of force on two objects, but if they moves different, if the displacement is different, suppose both are applying same force, if the displacement is now it is generally expressed as F into S. F into S. Though force and displacement both are vector quantity, but work done is a scalar quantity because it doesn't need any direction. But although they are comprising of two vector quantities. So suppose two persons are applying equal amount of force on two different objects, but they suffers two different displacement. So the body which suffers maximum displacement, the body which is displaced more, the work done, in that case work done is said to be more. If the two bodies suffers same displacement but two different forces, then the case in case of which the force is maximum, work done is greater. Clear? No need to see. So now there are three types of work done. Clear? Work done may be positive, work done may be negative, and somewhere else. So it means since work done is completed by applying force and displacement occurs, so based on the direction of force and displacement, work done is of different types. So let's see. Now first, sometimes that is when we apply force on a body, and if the body moves in the same direction of the force, it means if the displacement takes place in the direction of the force, the direction in which force is applied, displacement is taking place in the same direction. This is called work done by the force or positive work done. When we push or pull anything, isn't it? When we push, force is acting away from us, the body is also moving away from us. So it means both are taking place in the same direction. As you can see by the arrow, both are in the same direction. In case of free fall body also, force of gravity, that is weight acts in the downward direction. It is also displacing in the downward direction. So it is called positive work done or work done by the force. Here force itself doing the work. There is no, here we are not fighting against the force. There is no case of against the force. Next, that is work done against force, which is also called negative work done. Against force, it means force is acting in some direction and displacement takes place in opposite direction, or displacement takes place in one direction, force is in opposite direction. You can see force is acting in this direction, displacement is in this direction. Suppose a body is moving towards me, okay, then I am just opposing, I just want to stop it. So it is displacement is takes place in this direction, but I am opposing by stopping it, okay. So force is applied in the opposite direction. Or when we throw any object, any stone or any object against gravity, what does it happen? What will happen? The body will move in the upward direction. That is, displacement takes place in the upward direction. That is against gravity. Whereas due to weight, the earth attracts the body towards itself. That is, weight acts in the downward direction. So isn't it opposite direction? Displacement, body is moving in the upward direction. Weight acts in the downward direction. So both are acting in opposite direction. So it means in this case we are fighting against the force, isn't it? Fighting with the force, the body has to reach in the upward direction. So this is called work done against force, and this is called negative work done. Clear? Very easy. Now third case. Third case may happen when the displacement and force takes place neither in the same direction nor in opposite direction, but in some different directions. Clear? Now let's discuss. Now third condition, you can see, suppose this is a toy car, isn't it? This is a toy, and you have seen that is generally the children tie a string with one end of the toy, then pull it in this direction, and the toy moves in this direction, isn't it? So here in this direction you can see force and displacement. Okay, the direction of force and displacement are neither in same nor in opposite direction, but in different direction. Force is acting in this direction, displacement takes place in other direction, okay, and they make some angle theta in between them, isn't it? So it is neither in the direction of force, neither in opposite direction, okay. So what will be the expression of work done here? Now first of all, we will first find out the component of force along S. It means this is force, and we will find the component of force along displacement, okay. So what is the component of force? This is, we are going to find out OA. Again I am repeating, component of force along displacement. So this is the component of force, OA. So this is nothing but a right angle triangle. So base by hypotenuse equals to cos theta. So OA, which is our goal to find out, this is the component of force. OA is equal to F cos theta. So W is equal to F cos theta. You will say, sir, yes, no, this is since we are going to find out the component of force along displacement. So this is component of force F cos theta into S. So this is Fs cos theta. Clear? So this is the expression of the work done when force and displacement takes place neither in the same nor in opposite direction, or they will takes place in some different directions. It means they will create some angle in between them. Again, number 2. Now in this case we will find component of displacement along force. Previously it is component of force along displacement, now it is opposite. Component of displacement along force. Now suppose this is an inclined plane, isn't it? A person, this is a block or any load or luggage whatsoever, a person is just moving, applying force in this direction and pulls it, okay, and displace it according in its inclined plane and reach up to point B. So here force is acting horizontally, whereas the displacement takes place along hypotenuse. Clear? So now we will find the component of displacement along force. So this is the component of displacement. So again OA base by hypotenuse equals to cos theta. So OA equals to S cos theta. Since this is component of displacement, so we will put this value in the place of displacement. So W is equal to F into S cos theta, Fs cos theta. So this is, so both comparison are same, whether the component of force along displacement or the component of displacement along force, expression is the same. It means Fs cos theta. So when force and displacement makes no angle in between them, the plane expression is W is equal to Fs cos theta. It is generally in case of linear motion, okay. It means when force and displacement takes place in the same direction. But when both force and displacement make some angle in between them, that is theta. In that case, the expression will be W is equal to A phase cos theta, and this expression generally comes from this. Okay, now we will see. Okay, so since there is a theta, so depending on the value of theta, that is the angle between F and S, work done varies. So does it mean that since we have learned about the work done, so whenever we apply force, what will be done? No. If we push the wall, is there any displacement? So in spite of force is there, obviously immense amount of force, nobody will be able to move this wall by a single, isn't it, by a single inch. So not a trace. So this is zero work done, since in spite of application of force, displacement is zero. And if we don't apply any force, work done will be obviously zero. Theta is equal to 90 degree. When both theta is equal to 90 degree, you can clearly see cos 90 is equal to 0. What are the examples? Example is that the rotation of earth around the sun, the rotation of moon around the earth. In this case, you can see we have already learned about the centripetal force. So when a body moves in a circular path, each at every point its direction of motion, that is displacement, takes place along tangent, and force acts towards the center along the radius. Since tangent and radius are always perpendicular, so this angle, okay, so this angle, not this angle is always 90 degree. This angle, that is between displacement and force, is always 90 degree. So F plus cos 90 is equal to 0. So that is the work done. This is called minimum work done. Clear? This is minimum work done. Whereas we can say zero work done if any person coolie when carrying a luggage on his head, and if he moves on the works in the horizontal direction. So what will happen in that case? So in that case, its weight acts in the downward direction, and it works in the forward direction, displacement, isn't it? So what is the angle in between them? 90 degree. So again cos 90 is equal to 0. Okay. So when a coolie walks in the horizontal surface with a load or luggage in his head, in this case work done against gravity, I am saying against gravity is 0, but always there is a work done in case of friction, because each and every time he has to do some work against friction, isn't it? Frictional force, each and every moment it's opposing. Okay. So the question generally comes, a coolie walks in a horizontal surface with a luggage on his head. What is the total amount of work done? Here the answer will be, here the work done against gravity I am saying, gravity means in case of the attraction of the earth on the body. So here the work done against the gravity is 0. Why? Because the gravitational force, that is weight of the body, and the displacement are perpendicular to each other. So according to expression W is equal to A plus cos theta is equal to 0, but each and every moment he is doing some work against friction. So here only the work done due to friction exists. Clear? So total work done is not 0. If the question is what is the work done against gravity, this will be 0. Total work done is not 0. But if the same person, that is the coolie, okay, stands still with the luggage in his head, here in this case work done is not 0, because he is pulling the object, because he is holding the object, or if he lifts any object, isn't it? If he lifts any object, okay. Now if he stands still with the load on the luggage, in this case there is no displacement. So in this case work done is 0. But if he lifts any weight and hold it and put it on his head, during that case, during this incident, work done is mgh. Force is mg and the height, isn't it? If we just turn the linear distance along vertical, it will just grab some height. So it means when a coolie or any person, when we lift any luggage and we put in our head, then in that case work done is mgh. He is doing work against gravity, because he is fighting with gravity. Okay, he is pulling some distance, the load is reached, traveling some distance, that is h. But if he stands still without doing any work, in that case, now when once it is just reached into head, then he is not moving. So though weight is acting in the downward direction, now there is no displacement neither of the coolie nor of the load. So in that case work done is 0. But when lifting the object, lifting the load, work done is mgh. This is also called work done by gravity or against gravity. Okay, this is against gravity. Clear? So this is called work done against gravity. But if the object, okay, in case of free fall object, when an object moves in the downward direction under the action of a gravity. Now in that case it is called work done by gravity, because suppose this is the weight of the body and it is traversing the distance h. So since the body is moving in the direction of the gravity, so gravity is attracting the object and the body itself is just coming towards the gravity. So this is called work done by the gravity. So this is mgh. But if we throw any object against gravity, then it is called work done against gravity, since it is moving in the upward direction. Clear? Now, what is the minimum work done? W is equal to 0. When theta is equal to 0, W is equal to Fs, that is 0. You can see when force and displacement takes place in the same direction, angle is 0. So this is called cos 0 is equal to Fs. This is maximum. But negative work done, when it is negative work done you can see when force and displacement makes an angle 180 degree. It means when they are in opposite direction, angle is 180. So here we can write, clear? So here we can write W equals to Fs cos 180 degree. We all know that cos 180 degree value is equal to minus 1. So this is minus Fs, isn't it? So it is minus. So that's why it is called negative work done, isn't it? Because of this negative sign, 180 degree cos 180 value is equal to minus 1. Now I am talking about one important topic, that is I am talking about the work done by the gravity and work done against gravity, positive and negative work done. Now suppose when anybody, a work done can be both positive and negative, okay, with respect to two different force. Now when we throw any stone, isn't it? Suppose when we throw any stone in the upward direction, I have already discussed it is work done against gravity. But this is positive work done with respect to applied force, that is our muscular force, mind it. Okay, mind it. So when we throw any object in the upward direction with respect to our muscular force, we are applying force with our hand, isn't it? Muscular force is acting in the upward direction, so displacement also in the upward direction against gravity. So since both takes place in the same direction, so this is called positive work done. But mind it, with respect to our applied muscular force, not against gravity. When it will come, okay, in terms of gravity, it is negative work done, since gravity is acting in the downward direction, displacement in the outward direction. So the work done, same work done, can be both positive and negative, but with respect to some different objects. That is, with respect to applied force by our hand, it is positive work done, whereas with respect to negative gravity, it is negative work done. So I just want to clarify it through a very simple example. You can see suppose there are three persons, A, B and C. It is very clear that A is the tallest person, A is tallest and C is the shortest. In between B, just think the condition of B. B is both taller and shorter, but with respect to two different persons. Here B is taller in comparison to C, but shorter with respect to, that is in comparison to A. It means B is both taller and shorter. Just I explained about the work done, both positive and negative, but with respect to two different subject. Here B is taller with respect to C, but he is shorter with respect to A. So isn't it? So B is both taller and shorter, but it cannot be with respect to same person. With respect to A, it is shorter. With respect to C, he is taller. Just like the work done. With respect to the applied force, it is positive, and with respect to gravitational force, it is negative, isn't it? So this is clear. So this is the expression of work done. Clear?